Hi, welcome to this video. In today's video, I'm going to look at a very interesting problem. I'm going to put this function on the form of the Fourier series, okay? We previously did the natural log of cosine x. Today's video, we are going to do the natural log of sine x, okay? I'm going to use the Fourier series associated with the number complex as well as the Taylor expansion, okay? I'm going to use the Euler formula, e to the ix minus e to the minus ix over 2i equal to sine of x, okay? This is the Euler formula. So natural log of sine of x equal to natural log of, so natural log of sine x equal to natural log of ix minus e to the minus ix over 2i, okay? What I'm going to do now, I'm going to put e to the ix as a common factor, okay? So I will have e to the ix is multiplied by 1 minus e to minus 2ix, okay? Over 2i, okay? The whole thing over 2i. What I'm going to do now, I'm going to apply the logarithm rule on this one. So I will have natural log of sine of x equal to natural log of e to the ix plus natural log of 1 minus e to the minus 2ix minus natural log of 2i, okay? This one equal to ix, because I'm taking this one out of natural log of x, minus these terms. These terms I will have by simplifying this one, not equal minus this term equal natural log of 2 plus natural log of I, okay? Minus natural log of 2 minus natural log of I plus this term plus natural log of 1 minus e to the minus 2ix, okay? So if you take a look at here, natural log of I, because we have e to the I pi over 2 equal to cosine pi over 2 plus I sine pi over 2, okay? So this one equal to 0, this one sine of pi over 2 equal to 1, which is I, okay? So this term, so e to the I pi over 2 equal to I, which is natural log of e to the I pi over 2, which is I pi over 2, okay? I'm going to replace this term by I pi over 2. So I will have ix minus natural log of 2 minus I pi over 2 plus natural log of 1 minus 2ix, okay? So this is the first equation. I'm going to put this one as the first equation. This is the whole thing equal to natural log of sine x, okay? So natural log of sine of x equal to ix minus natural log of 2 minus I pi over 2 plus this term natural log of 1 minus 2ix, okay? Let's call this one equation number 1, okay? So as you see here, this is the first equation that I get from the last expression. This is the first equation. I'm going to work on the second equation, okay? So the same equation, natural log of sine of x, okay, equal to, I'm going to use the Euler formula, e to the ix as a number complex minus e to the I minus e to the minus ix over 2i. This one I'm going to factor out. What I'm going to do now, I'm going to switch these terms and put the minus sign in the denominator, okay? So this one equal to natural log of I'm going to use this technique in order to pass through the Taylor expansion. Okay, natural log of is become this one is become first minus ix minus e to the ix, okay, over minus 2I. So this one natural log of sine of x equal to natural log of, I'm going to multiply out, I'm going to put e to the minus ix as a common factor, okay? So I will have e to the minus ix equal to 1 minus e to the 2ix, okay? The over this minus 2I become 2I cubed, because minus 1 equal to I squared as a complex number. I'm going to apply the logarithm rules, equal to natural log of e to the minus ix plus this term plus natural log of 1 minus e to the ix minus natural log of 2 e to the 3. Okay, so now natural log of sine of x equal, I'm going to simplify this one. So this one is giving us minus ix, because I took this minus ix out of natural log of natural log is become minus ix plus this term natural log of 1 minus e to 2ix. I'm going to simplify this one out, is giving us minus natural log of 2 minus natural log of I3. Okay, I'm going to explain this one. Natural log of I to 3 equals 3 times. I'm going to take this one out by applying the natural log rule. We will have 3 natural log of I. Okay, as we said before, this 3 natural log, this I equal to e to the I pi over 2, okay, which is 3. I'm going to take this I pi over 2 outside of this logarithm. I will have 3 is multiplied by, I will have 3 pi over 2 I, okay. If you take a look at unit circle, we have minus pi. We have chosen the interval x. We have x belongs to this interval minus pi. This is minus pi. If you put this one on the unit circle, you will have 3 pi over 2, which is 1. In the same time, equal to the minus pi over 2. Okay, they are then at the same point. Okay, so I'm going to replace this 3 pi over 2. I'm going to replace 3 pi over 2 is multiplied by, I'm going to replace this 3 pi over 2 I by minus pi over 2. Okay, so now I have this expression as we have here. So now natural log of sine of x equal to this term minus ix minus natural log of 2 minus this term. We already proved this term, which is 3 pi over 2I, which is minus pi over 2, which is plus, because with this minus sign become plus pi over 2I. Okay, so now plus this term plus natural log of 1 minus e 2 to the ix. This is the second equation that I have ended with. Okay, I'm going to take these both equations at the top and continue with our problem. If you take a look again at these expressions, we have the same equation is written on two different forms. Okay, what I'm going to do now, I'm going to add the first equation on the second equation to see what's the expression. So that's mean 2 times natural log of sine x. So this one is 2 times natural log of sine x by adding equation number 1 on equation number 2. Okay, so ix will be cancelled out because one is positive, the other one is negative. We will have minus 2 times natural log of 2, minus 2 times natural log of 2. Again, pi over 2i will be cancelled out as well, because one is positive, the other one is negative. We are going to be left with this one, so I will have plus these two terms, which are natural log of 1 minus 2 to the ix, plus natural log of 1 minus e to minus 2ix. Okay, so what I'm going to do now, if you take a look again at here, I'm going to apply Taylor formula. We have natural log of 1 minus x, okay, equal to minus sign outside, minus this sum, x to the n over n, as n goes from 1 to plus infinity. I'm going to replace x with e to 2ix, okay? So this one equal to, I will have natural log of 1 minus e to 2ix equal to this minus sum 2 to the x, 2 to the e and x over n, as n goes from 1 to plus infinity. The second expression I will have equal to minus sign outside of this sum, 2i and x over n. What I did here, I just replaced x with this term, e to the 2 to ix. The second term, I replace it with minus 2ix, as n goes from 1 to the plus infinity. Okay, I'm going to put these two terms into this origin equation. 2 times natural log of sine of x equal to these terms, which is minus 2 natural log of 2, minus 2 natural log of 2. I'm going to factor out, I'm going to put minus sum of 1 over n as a common factor of both terms. I will have minus sign outside of this sum, which is, as n goes from 1 to plus infinity, factor these two terms, e to the I and x, plus this term, which is e to the minus 2i and x. Okay, so what I'm going to do now, I'm going to divide over 2. I'm going to divide these two terms over 2, in the same time multiplying by 2. Okay, as I did nothing, just dividing by 2 and multiplying by 2. Okay, so this term equal to sine, this term equal to cosine 2nx. Okay, what I'm going to do now, I'm going to divide, so this one equal to 2 times natural log of sine x. I'm going to divide by 2 on both sides. Okay, so I will have natural log of sine of x equal to minus natural log of 2 minus sine outside minus this sum. This term is cosine, as we mentioned before. This is cosine 2nx. Okay, I'm going to replace this one with cosine, so we'll have cosine 2nx over n, as n goes from 1 to plus infinity. Okay, so I'm going to put this one at the top and continue with our problem. We have ended up with this expression. We found the Fourier series coefficient, a sub 0 over 2, which is minus natural log of 2, and also we found a sub n, which is 1 over minus 1 over n. Okay,